Hello developers. In this video we introduce JSON and look at some ways to manipulate JSON data, including accessing data through a web server based API. JSON stands for JavaScript Object Notation, and since it's JavaScript, it's automatically wonderful and amazing. It is a cross-platform tool, meaning that it's very useful for exchanging data between disparate systems. If I'm running Windows and you're running a Mac, this is a good way to exchange data because all the data is in a text format. We don't store any binary representations of floating point numbers or integers, which are represented differently in different CPUs. That means that we can always read information without knowing who created it. I can create a JSON file in a Windows machine. I can create a JSON file on a Mac, and they will be able to talk to each other back and forth. JSON data is generally organized into key value pairs, which you may think of as a dictionary. Those are delimited by curly braces, and then the values can be arrays delimited by square brackets, or another dictionary, or individual entities like strings, booleans, numbers, and even objects, or another dictionary entirely. But it's really not that complicated. There are servers that you can make requests of that will respond to you with JSON files. And I like this one because it's free, it's interesting, and it's easy to use. So in the examples that we will go over, I have obtained a free API key, which I encourage you to go get your own, but for the purposes of these examples, we're using my key. And then we'll make requests of this government server and receive information back about our national parks. We can use these pre-constructed URLs that I'm providing in the slides to browse what we're doing is making a request of that server using the API key as an authorization token and a park code. In this particular case, we are requesting information about a particular park, and that information is returned to us in a JSON string. My browser immediately recognizes that as a JSON string and converts that into a little more pleasant format, something that we can collapse and browse. But if we click on the raw data tab here, this is what actually came back to us from that server. And this isn't too bad. It's still human readable and it's still delimited well, but it's kind of run together and it would take a little bit of study. So navigating the JSON interpretation is a little bit more easy, and I find this an invaluable tool when I'm trying to write code that parses a JSON string, because I can see where the arrays are. In this case, there's a one element array called data, and the data array has a whole bunch of key value pairs and other neat things in it as well. And there are way more APIs available to you at that same site. So take some time, explore the site, explore other API sites, and learn more about JSON and how it's used. Here's a little bit of a drill down into what we're getting back from that API server. Now in this particular case, I'm asking for a slightly different data request, but it's similar. And I've broken it up into a few lines. I've taken that raw data and kind of separated it into some key value pairs. Make it a little bit easier to read, but again, you're still better off plugging this into your browser and letting your browser reformat this into a very nicely structured JSON representation. Now, the data key value pair, in other words, the key is data and the associated value is an entirely different animal than the other three key value pairs that we see in this data. The data key has a value that is yet another dictionary. And it's actually even more than that, because if you look closely, the value associated with that key called data is actually delimited in square brackets, meaning it's an array. And that tells us that that array could contain 0 or more of something. In this case, it contains 0 or more dictionaries. So a key value pair is a key, and in this case, a value that consists of more dictionaries. Still not difficult to parse once you understand the structure. In this example, we're asking for code info on two parks, ACAD and GRSM, and if we process this URL through our browser, we will see that the data key, while we knew it was an array, it only had one element, but now that data key has two elements because we asked for two parks. So the JSON string contains a key value pair consisting of a key named data and a value consisting of an array, a two-element array of dictionaries. And it looks a little bit daunting, but once we get the hang of collapsing it and browsing it, we can translate that knowledge into code, and we can pull out anything we want based on the keys. And even if we don't know the keys, we can still step through this data, but it's much more convenient if we have the keys and we know the structure in advance, which sometimes we will and sometimes we won't. Let's take a look at some code. I provided a donor project for you, so hopefully you will take the time to clone it to your desktop and open it in Visual Studio. If you'd like to fork it and clone it, that's great. If you think you have some improvements to suggest, fork, clone, make your enhancements, modifications, extensions, commit and push, and do a pull request, and I'll be happy to consider what you've done. The code starts in the program class, which is the standard entry point for a console application, and it calls a method called demo in the parsing class, and I've commented out the other method. We'll get to that in a moment, just so the screen isn't too cluttered up when we talk about this. So let's look at the demo method in the parsing class. This method submits a URL to the same API server that we looked at a moment ago in the slides, and it asks for information about one park. So the JSON string returned from this data request will be very similar to what you saw on the slides a moment ago. And then we pass that JSON string to a print method. I'm just being modular here. I could have jumbled all this together into one method, but I just kept it modular. The print method demonstrates how to traverse how to process that JSON string if I know the names of the keys and how the keys are organized, if I know where the dictionaries are and where the arrays are and where the values are. So the first key value pair is easy to get. It's right out in the front. It's not buried in an array anywhere. It's not buried in a list. It's simply a key value pair. The key is called total, and the value is whatever is associated with that key total. And it's so easy to access. All I have to do is use the values object and then the total word, which is the name of the key. So as long as I know the name of the key, I can very easily grab the value for that key. Now, how did I get values? I called one method called Deserialize Object. Where did that come from? Well, let's right click on Deserialize Object and say go to definition. And we have a mild panic. Cannot navigate to the symbol under the caret. Let's try again. Are we sure we can't do that? Right click, go to definition. Okay. What in the world is this? What is this jumbled mess? Well, I noticed right away that it appears on the right side of the editor window, meaning it's not quite our code, but somebody else's code. So let's close that and put aside our panic for a moment, and let's just hover. There's our answer. The Deserialize Object method and the JSON Convert class are from Newtonsoft. It's not something that we wrote. Therefore, if you go to Tools, NuGet Package Manager, Manage NuGet Packages for Solution, you click on Installed, you will see that we have installed Newtonsoft.json, a high-performance JSON framework for .NET. It's been downloaded about 27 gabillion times, and we've installed it in our project. It's free, there are no royalties associated with it, and we can use it. What does this method do? It takes a string, which is the raw data returned by that API server, and it deserializes it into a dictionary. We can take a string from the government API server and automatically plop it into a dictionary data structure, and we're off to the races. Look at the structure of the dictionary that we are deserializing into. The key is always a string. The value associated with that key is, and we're kind of punting here because we don't know what it's going to be. It could be a string, it could be another dictionary, it could be an integer, it could be a date time, it could be some other object. So we just call it an object. That's the most basic data type there is. Everything can be converted to an object because object is the base class for every type of every class in C#. And that's the best we can do. Since we don't know what kind of values will be in this dictionary, we'll just call them all objects for now. That's all we can hope to do. All right, so after we printed out the total value associated with the total key, we know that the data key is associated with an array of dictionaries because we browsed through that JSON file earlier. And since we know that, we can convert the data, the value associated with the data key, into an array. This J array is a Newtonsoft construct. Again, not one of ours. And then we iterate over that array. Now everything in that array is going to be a J object, which again is another Newtonsoft construct. But the beautiful part is we know all of the keys in each element of that array. We know that all the array elements in that data key are key value pairs. And we can reference them by the key names: title, ID, description, category, URL, part code. And if you go back to your browser again, actually, let's go get the URL. Scroll back up. Let's just let .NET do it for us. There it is. So .NET has browsed to that URL for us. And there are the key value pairs in the data, in the value section of the data key. There's title, ID, description, category, URL, and part code. If you flip back to the software, we have title, ID, description, category, URL, and part code. This works because we know two things. We know the structure of the data, we know what the key value pairs are, and we know the names of the keys. Finally, after we've iterated over all of the data array elements, we can hit two more simple key value pairs at the very bottom of that JSON string, which are called limit and start. If you flip back to your browser window, you can see those are also visible in that rendering of that JSON string. Again, if you don't like this, flip back over to the raw data representation and you'll see exactly what the Newtonsoft classes see when they deserialize that string. Whatever works for you. Continuing on, the second method that we run is called traverse. The traverse method doesn't care about the names of the keys. It simply muddles its way through the structure, looking for occurrences of key value pairs, and prints out whatever it can print. I don't know what the keys are. I don't care what they are. I really don't even care about the structure that much. I'll figure it out as I go along. I know that I can deserialize again, just like I did before. So I've deserialized into something called values. Values is going to be a dictionary. And then I can iterate over the dictionary. You can iterate over any dictionary. It doesn't have to be a JSON or originating dictionary. And then I just start figuring out what I've got. I know that the data type is available to me for each of those key value pairs. And I know that if it's an array, I can iterate over that array. I know if it's an object, I can start over and begin traversing it. That makes this function reentrant or recursive, if you wish. And if I have nothing else, if it's not an array, if it's not an object, then it's just a simple old value and I can print it out to the console. Let's run this. Again, if you go back to program.cs, you can see that I've still got the serializing .demo commented out. The only thing we're going to run is the parsing demo. Control F5. There's the output of that program. I encourage you to take some time to look at it and notice how easy it is to traverse the JSON data by key or simply by feeling your way along and looking at the data types of each of the values in the key value pairs. It works both ways. Okay, go back to program.cs again. Let's comment out the parsing demo and let's uncomment the serializing demo. And let's take a quick look at that before it runs. The serializing demo does something a little different. Instead of asking for information from an API server, it simply creates an instance of a class, serializes that to a JSON string, writes it to a file, and then turns around and reads it from the file and deserializes it. And this is the entire extent of that code that we're running. Before we do this, jump over and take a look at Fruit. That's my donor class. The Fruit class has a name, a weight, a date picked. I purposely added some less than standard or less than popular data types here. I didn't want to use just strings and integers. That's too easy. So I threw in a date-time class. The fruit object has a date-time member, not just integers and strings. And then to be even more obtuse, I created an enumerated data type called condition, and I defined 4 stages of fruit. It could be unripe, ripe, overripe, or rotted. And I added a getter and setter for the enum. Then to be even more crazy, I created an array of strings. And the array of strings is called quality, and I don't even know what's going to be in there. It could be anything. But I can still serialize this object because the Newtonsoft utility is pretty useful. It knows what to do. Not a lot of trickery in here. I've got a toString method that prints out a string representation of the fruit object, and I've got a constructor that accepts all of the properties of the fruit object and assigns them to the properties dynamically. And I've got an empty constructor which doesn't do much of anything, and I probably don't even need it. Okay, go back to serializing.cs, and we create a fruit object. We call it fruit. It's an apple. It weighs 10 ounces. It was picked on 1/1/2020 at 4 p.m. It is ripe, and it has a quality. Notice here's the quality. All right, for the first time, I'm defining the quality of that fruit. It's not part of the class definition. The serializer knows nothing about it, but it's still going to work. Organic, free range, and pesticide free are all the qualities of this fruit. And somehow they will be serialized magically. How do we serialize the object? We call a serialize method. Who wrote that method? I don't know. Let's figure it out. Let's hover. Let's right-click on serialize, go to definition. There's the serialize method. I wrote that. How about that? What does it do? It takes an object. Notice right away that it doesn't know what kind of object it's taking. It's just taking something called object. So again, it doesn't know it's a fruit, but it still works. And it takes a file path, which in this case is just wherever I'd like to write the serialized JSON. If the file already exists, it's deleted. It creates a stream writer. It creates a JSON writer based on the stream writer. Here's the magic right here in line 23. It serializes my object through the JSON writer and into the file on the disk. That creates the file. Then it closes the writers, and it's done. This little bit of code right here is all that's necessary, and more than is necessary actually to serialize an object. And while we're here, let's look at deserialize. It's even more complex. Look, one line of code. It calls a Newtonsoft method called Deserialize Object, which is parameterized. Okay, the little t there means that some data type will be provided when that method is invoked. In our case, we're providing fruit. And we read the JSON string in one swoop by calling read all text, and it's deserialized. Boom. What could be easier? Let's make sure we're ready to run. Go back to program.cs. We have uncommented serializing.demo, and for convenience, we have commented parsing.demo. We run it. Blip. Before we look at the output, let's go look at the file that it created. So I'm going to right-click on the solution, open in File Explorer, and I'm going to make your life easier. I know where the file is. I will drill down and drill down and drill down, and there's the file, fruit.json. That was created by my program. I can open that with any text editor, Notepad++, that has some color in it. There is the JSON string that Newtonsoft generated for me that represents the contents of that fruit object. Notice the quality key value pair. The key is quality. The value is in square brackets. That means it's an array. And inside the array are 3 values. Not key value pairs, just values. That's an example then of a key value pair where the key is a string and the value is an array of strings. Square brackets, remember, array. Curly brackets, remember, dictionary. If you can keep those two things straight, you've got 99% of JSON figured out. Square brackets are an array. Curly brackets are a dictionary. In this example, everything is a dictionary as you would expect. The whole thing is contained as a dictionary. And inside that dictionary is a key value pair where the key is called quality. The value is an array of strings. Very powerful. To complete this demonstration, let's run serializing.demo and capture the output. We let it go by a moment ago. We didn't talk about it. Control F5. The output of that method, the first thing it does is serialize, and I've got a little bit of commentary here. Serializing fruit object to JSON file. And then what you see after the colon is the toString method for that fruit object. Then deserializing fruit object from JSON file. There is the toString method for the new fruit object that was created from the contents of that serialized JSON file. Now, the output of this method just kind of demonstrates that it does work. We wrote something to a file, we read it back, and we got the same information back that we wrote originally from our first fruit object. It appears to work. So take some time. On the JSON.org homepage is a very, very useful and illustrative set of diagrams explaining what values are, what keys are, what arrays are. I'll just jump in and make some comments here. Notice the array, which we've already talked about, has to start with a square bracket, and then you traverse these paths. You add values, you add commas, you add values. Eventually you end up over here with a closing square bracket. So this is the entire syntax definition of creating an array. As long as it starts with a square bracket, ends with a closing square bracket, and consists of values separated by commas, it's an array. Well, what's a value? A value can be anything from this list of things separated from other values by white spaces. A value can be a string, which you would expect to be in quotes, a number, which you would expect not to be in quotes, an object, which you don't even know what that is because it hasn't been created yet, but it could be a fruit. It could be anything. An array. A value could be a square bracket delimited list of other values. A value could be a Boolean, true or false, or a value can simply be empty. Again, if you can read this syntax, you can create your own JSON files. Well, if a value can be a string, how do you make a string? Here's the syntax for creating a string, and it's probably the most complex of all the diagrams that you'll look at. It starts with a backslash or a quote, and it has other weird characters in it. I don't know what a solidus is. I'll have to look that one up. That's new to me. Or any of these characters. What does a number look like? Here's a diagram for creating a number. What does a white space look like? They're very thorough on this page, okay? They tell you what everything is allowed to be, and you could probably implement the entire JSON format by following these diagrams in, what, a weekend? It's really a trivial operation. So take the time to study this, and then go down to the bottom and pick one of these JSON libraries at random and implement it in a random computer programming language, because I know you like to do that. Thank you.